Okay, so here's a projectile motion problem. Example 3 in the book. So we're throwing a projectile at 35 meters per second upwards here off of a 70-meter high cliff. So our initial speed is upwards 35 meters per second. And the projectile is going to rise up, momentarily come to rest, and then begin to fall down. So first we'll find the time to the top. Now, key information is at the top we're momentarily stopped, so the final speed is 0. It's also true that we're in free fall, so the acceleration is downwards 9.8 for this part of the motion. So we'll use VF. Let's clean that up. VF is VI plus AT. So the final speed 0 at the top, momentarily 35 the launch speed, downwards 9.8 the acceleration. So minus 9.8 t I'll bring over to this side, it becomes positive 9.8 t. And I'll divide both sides by 9.8. And then I'll have the time, and that works out to be a little bit more than 3.5 seconds. .57, I think. 3.57 seconds. Now that's the rising time. The time the object is going up to the top. Now the distance to the top, that's next. We could just use the displacement equation. I'm just going to, for a change, use average velocity times time. Because, of course, the initial speed's 35, the final is 0, because we're momentarily at rest at the top, and then the rising time is 3.57 seconds. So if you work that out, 17.5 times 3.57, it's 62.5 meters of rise. So that means from here to here is 62.5 meters. So for the maximum height above the ground, you just have to add the 70 meters of cliff height plus the 62.5 meters of rise. Just on our little diagram here. So up here, that's 62.5, and this is 70. So we're now 132.5 meters above the ground. Now for the falling motion, here's our cliff again, we're going to start off in a state of rest, because we're starting off at the top. We're going to go downwards 132.5 meters, and our acceleration is downwards 9.8 meters per second squared. So if we want the time, we can use the displacement equation. D is VIT plus half AT squared. The displacement is the downwards 132.5. The initial speed, our initial point is up here at the top, so it's momentarily at rest, so that's 0. And 0 times t is just 0, so that term disappears. The acceleration is downwards 9.8. Now half of downwards 9.8 is downwards 4.9. And to solve this equation, we're going to divide both sides by minus 4.9. And then we'll take the square root. Both sides. So the square root of t squared is just t, and that works out to be 5.20 seconds to fall to the ground. So now the total flight is just the rise time plus the fall time. So we had 3.5 seconds plus 5.20 seconds And so that is 8.77 seconds in the air. And so that concludes the projectile motion.